So this is lesson 8.6, and we'll make it A. In intermediate algebra, this has to do with variation. And you're going to use this quite a bit. So let's just get started here. And we have two different types of variation we're going to look at. And one is as one number gets bigger, the other number gets bigger. So let's say, for example, that as you work more hours, so as the number of hours go up and how much you work, the number of money you make is also going to go up. And that is called direct variation. And so the way that works is one part of the number, as one number goes up, the other number goes up. As one number goes down, the other number goes down. So, like, oh gosh, let's say the higher your grades go, the more free time you have. The lower your grades are, the less free time you have. That's direct variation. As one goes up, the other one goes up. As one goes down, the other one goes down. All right, let's look at the other one. The other one is called inverse. It varies inversely. And that means as one goes up, the other one goes down. So, for instance, as you run faster, the time it takes you to get somewhere becomes less. All right, so as one goes up, the other one goes down. As we look at these, we're going to come up with two different equations to solve inverse and direct variation. And we're going to start with the direct variation. Direct variation has an equation that looks like this. Okay, so let's just look at that. We aren't even going to look at inverse variation yet. That's direct variation. All right, so they will tell you in the story problem whether or not the equation varies inversely or varies directly, and then you will know which equation to use. So this first one is, it tells you in example 1, y varies directly with x. There's the equation you use. First thing you do, write down the equation. Then they start giving you information. If y is 15, and x is 5. Okay? Find y when x is 7. All right, so first step to doing these is write the equation down. Second step is basically find k, because that's all that's left here, right? So if we take 15 over 5 equals 3. So k is 3. So that's the next step. All right. The third step is look at the other information they give you. Find y when x is 7. Well, we found k, so we don't have a k there anymore. So when x is 7, y is 21. And you're done. Okay, not too terrible. All right, let's try another one. Let's try the second example there and follow those steps. Skydiver jumps from a plane. As with any object that falls to the earth, the distance the skydiver falls is directly proportional. It used the word directly. We use this equation. You see the word directly. We don't care if it says varies directly, is directly proportional, or what. We're going to write y equals kx. All right. Varies directly to the square of the time he has been falling until he reaches his terminal velocity. All right, so let's write this equation like that, y equals kx, but they're giving us some other information here. They're giving us a little bit more than just y equals kx. They're saying that y is directly proportional to the square of the time. So instead of an x here, I'm going to write it as a t for time. And it says we're squaring the time, right? So y equals k times t squared. Okay, so they're also saying the distance is directly proportional. So let's call that distance instead of y. So it doesn't matter what variables you use, it's just when you use d for distance and t for time, it just reminds you a little bit more of what they stand for. Alright, so A says, how far will he have fallen in 3.5 seconds? So when t is 3.5, how far will he have fallen? Alright, so the next part of this is to, I don't know how they got there, is to find out what our k is. Well, let's see if they gave us any more numbers. Let's see. If the skydiver falls 64 feet in the first 2 seconds of the jump. So we're going to look at this formula there, and it says 64 equals k, and then they say 2 seconds. So they have to give us enough information to find k. So 64 equals 4k, divide by 4, divide by 4. So k is 16. So that's our second step, finding out what k is. Our third step is to take d equals k t squared and answer the questions once we have the equation. In fact, that isn't even kt squared anymore because now we know what k is. So there's our equation that we're going to use in order to solve this. Alright, so now back to A. How far will he have fallen after 3.5 seconds? We're looking for D, 16, and we have 3.5 that we're going to plug in there for T. Don't forget to square that. So when D in 3.5 seconds, we get 196 feet for his distance in 3.5 seconds. When we plug 3.5 seconds in there. Okay. Part C says how far. Let's see if I can do it in yellow and kind of keep as much as I have there. I'm going to skip the graph. I'm not going to worry about doing graphing. How long will it take him to fall 256 feet? So again, I'm still using that formula. And they're asking how long it'll take him to go 256. So now distance they gave us, and we're trying to find time. So that being the case, we're going to divide this by 16, and if you're really smart, you know that 256 divided by 16 is 16. So t equals 4. So that's how long it'll take him to fall 256 feet. Alright, so that's direct variation. Let's go ahead and learn how to do inverse variation. So inverse variation is just a different formula. Y equals kx is direct variation. Inverse is y equals k over x. That's the only difference. K is always on the top, but the x in inverse is on the bottom. And that's pretty much it as far as that is concerned. So let's go ahead and look at example 3. The volume of a gas is inversely proportional, so I know I'm going to use that formula. Alright, so, and I'm going to rewrite it because it says the volume of the gas. So I'm going to write that, volume of the gas, equals K over pressure of the gas. Okay, so I'm just using VG and PG as volume and pressure. In fact, since we're not really doing much, we can just kind of get rid of that and just make it V equals K over P. Okay, so there's my formula. Next step is to find K. To find K, it says if a pressure of 48 pounds per square inch corresponds to a volume of 50, so my volume. Alright, so there's what I can do to find my K, and I do that and I find my K is 2400. Now I'm going to rewrite this with the information I know. All I did that for, all they're giving you that information for is so you can find what K equals, so you can put that in the formula. Okay. What pressure is needed to produce a volume of 100? So they give us the volume of 100. That's what they want. And they want to know what pressure it's going to be to do that. So, cross multiply. Divide by 100. And the pressure is going to be 24. And that's it. So we're going to finish up 8.6 with joint variation and other variation combinations. Not really too terrible. We're going to do that in the next video.